Okay, Mac 132, Blueprint Reading 2, the Wednesday class before our test next Monday. What did we learn today? Well, I went over quite a bit on wall thicknesses and distances in prints based on worst case scenario. And I want you to remember that you have to apply every tolerance to every dimension that you see in order to get the answer right. Whether you have to divide it by 2 or whatever is going to be apparent on the print. But it's very important for us to be able to gauge these wall thicknesses and distances before we go out and make parts, so that we can keep our parts in tolerance and know their effect on the eventual end strength of the part. So when you see a basic dimension applied to like a bolt circle, you don't apply any tolerances to a basic dimension. However, if on the bolt circle is a hole that says +3 or -2, well, you add the +3 and divide by 2 if necessary to find the radial distance of the hole. If there's an outside dimension, then you will find the worst case scenario based on the title block or any other information for the smallest dimension it can be, so that we can know when the hole is positioned the maximum off of its true location that it's able to be, plus the biggest that the hole can be, and then the distance from the edge of the hole to the edge of the part based on its smallest allowable size. So I gave you a pretty good idea that that's going to be on the test, and it might be several times. What else did I talk about? I talked about the profile of a line and the profile of a surface. This is a 2D geometric tolerance. This one is a 3D. So that if I were over here and I was talking about the profile of these lines and they had a 10 thousandths or a 20 thousandths diameter tolerance zone, I would only be talking in 2D and those lines. If I'm talking about the 3D profile of a surface, then I'm talking about the whole side of this thing too, on either side. So I'm going to get perpendicularity, parallelism, and all these other things if the profile of this surface falls within that 20 thousandths diameter band that it has to be. That not only gives us parallelism and perpendicularity, but it also tells us how big and how small this distance can be. So you don't have to put on the print, if you have a profile tolerance, you don't have to put the actual dimension that this has to be on the print. You can refer to the basic dimensions and then apply the profile tolerance zone to find that distance maximums and minimums. So profile of a line can get kind of hairy, but the book tells me that it's underused and that you can get several good things from it. These are the perpendicularity of this surface, the parallelism of this surface, and the location of the dimension inside this tolerance zone. Remember also that circular runout is a 2D and total runout is a 3D dimension. If we have a part that's that runs out 0 here, and it is at 1.0 right here, and in this exaggerated place, it's 0.990, and we had a total runout tolerance of 5 thousandths, or no, let's say of 2 thousandths, a total runout. Well, I'm going to have a 5 thousandths diameter gap here that has to be included as I move my dial indicator. It's going to fall 5 thousandths in this, and then go back up to 0 here, say, and it will be no good to the total runout tolerance of 2 thousandths. So you can see if we had a runout of 0 here on this end, that's 2D. If we have to take in the entire surface and any deviations in the surface along that area, then we lose, and then we have to add that to the paperwork for total run out. The total run out of this piece is going to be 5 thousandths, not 2. So what do you get if you have made this correctly, and this is not the case with total run out? You will also get straightness and cylindricity. You'll get the diameter correctly. There'll be no taper. There's all kinds of other things that go along with total run out that will ensure the geometric tolerancing of the part and its performance in assembly. After I explained those two things, I went over things that you can expect on the test, and I guess that I'll just leave it like that. You can expect this test to have a couple of blueprints and look a lot like the emailed second test that I gave you before. I'm going to ask you to prove you know how to apply GD&T, and you will be asked to interpret from left to right a somewhat complicated feature control frame. Good luck, and we'll see you Monday.